Okay, today we're going to take a look at equations of circles. And in a coordinate plane, a standard equation of a circle with a center at the point hk and a radius of r is x minus h squared plus y minus k squared equals r squared. Okay, at this point, we'll go ahead and pause the presentation so the students have time to copy down the general equation of a circle. Okay, we take a look at the pictures here, the front page of your notes. You'll notice that there are three separate circles, and all of our circles have a center at 0, 0. Now, one of the other things that you're going to want to notice is that with these problems, that each of your equations looks the exact same down here, x squared plus y squared, x squared plus y squareds. Okay, for all three of those that I've just circled, they're all x squareds plus y squareds because their center is at 0, 0. And we know that x minus 0 is just going to give me x, and y minus 0 is just going to give me y. So I've got x squared plus y squared. Remember that that's going to equal your radius squared. So if you take a look here on the one on the left, you're going to notice that your radius here is 2 units out. Okay, so since our radius is 2, we're going to square that, and 2 squared is going to give me the 4 that we have down below. On our middle one, same thing's going to happen. This time our radius is 3 units out. 3 squared is 9, and you notice that that part's there in that circle. Okay, and then lastly, on the last one, you're going to notice that your radius on this one is 4 units long. Well, 4 squared is 16, and that's what you get there on the right-hand side of the equation. Now, taking a look at the second series of pictures on that front page of your notes, you're going to notice that you're going to use the graphs and equations of 3 circles with different centers. This time, each circle has a radius of 2. And you're going to notice that over here on the right-hand side of each of these equations that you have a 4. Okay, so that's how that's going to work. And the other thing that you're going to notice is with each of the centers being different, notice that your coordinates here are both positive, and that the signs inside both sets of your parentheses down here are negative. Everything is always an opposite sign inside parentheses. And that's going to be true with any graph shift for any type of conic section that you do, whether it's the circles here in this unit, or if it's going to be something that you're going to see next year in Algebra 2 when you deal with conic sections, or in pre-calc, whenever that may show up again. On our next one in the middle, you're going to notice that your x-coordinate's -2. Notice that the sign inside your parentheses is a plus. And similarly, on our last set of problems over here with our equation, you're going to notice that both of our coordinates are negatives, and inside of our parentheses, our signs are positive. So when you're taking a look at the graph, it is important that you understand that your signs are always going to be opposite inside of the parentheses. That's one of the general forms for equations, and quite honestly, transformations of any type of conic section. Okay, so make sure that you're aware of that. Okay, flip over your notes and into the second page. We're going to look at how to graph a circle. Okay, the circle that we have here to graph, it's got a circle with an equation of x squared plus y squared equals 81. Now, that tells us that our center is where at. Okay, well, there's no parentheses for x or y, so that tells you that your center of your circle is at 0, 0. In order to graph a circle, what we're going to do, remember that our equation is x squared plus y squared equals r squared, and if r squared is 81, our radius is 9. And that's going to be important because what we want to do then is go from our center dot, and we're going to count 9 units to the right, 9 units up, 9 units to the left, and 9 units down. Now remember that you do have a 10 by 10 circle, or a 10 by 10 block, so you can count back in 1 unit. So you've got the 4 dots that are going to set up your circle, and then what you're going to do from there is you're just going to sketch your circle. It does not have to be perfect, but you want it to be curved and hitting each of those 4 dots. Okay, obviously it's not a perfect circle, okay, which definitely sounds like a band name of some sort, but it does have to have some curves to it. You don't want it to be square. Square circles do exist, but that exists in taxicab geometry, and that's a whole separate piece in and of itself. Okay, looking at the next section here in the notes, we want to write our standard equation of a circle with our given information. And remember that when we're writing the equation of a circle, we want to go opposite of the coordinates of our center. So since my center here has a point of +1, inside my parentheses, I'm going to make it minus. So I've got x minus 1 squared. If you need to write y minus 0 to help learn it, write down y minus 0 because my y piece has a center coordinate of 0. But it's certainly okay just to write y squared. And our radius is 2. Remember that the right-hand side of the equation is r squared, so that needs to be a 4. Okay, on our next one, we're going to start with our center. Okay, so we're going to have x what? Okay, it should be -3. squared plus y plus 2 quantity squared, but it doesn't give us our radius. But if you look at your circle, you're going to notice that your center at -2 has a point in a circle with a y-coordinate of +4. Because both of those x-coordinates are the same, the distance from your center to the point in a circle is just how far you're moving in the y direction. So you go from -2 to +4, you're moving how many units? Okay, exactly, it's 6. So we're going to make 6 squared be the right-hand side of our circle. It's equation, and that's 36. Okay, as we move forward, you also have to be able to go through your formulas or your circle equations and work backwards in order to find the center and radius. So we take a look at our center here on number 1. We know that we're going to go opposite sign of our coordinate in with x. So since I have x plus 3, that's going to give me an x-coordinate of -3. And since our y-coordinate is -5, y minus 5 in the parentheses, that means my y-coordinate is +5. And remember that 36 is r squared, so our radius in this case needs to be what? It's 6. Okay, looking here at number 2. My center, if I have x minus 4, is +4. My y-coordinate should be -1. And then the radius is the square root of 49, which is 7. Are there any questions that are in a general form for the equation of a circle? Okay, at this point we'll move on forward here to our next problem. And this is one of the test questions that was released from the end of course test. Johnny wants to find the equation of a circle with a center of 3, -4, and a radius of 7. He uses the argument shown. There are 3 highlights in the argument showing missing words or phrases. For each highlight, click on the word or phrase that correctly fills in the blank. Let xy be any point in a circle. Then a horizontal distance from xy to the center is blank. Okay, now, remember that your horizontal distance is how far you're moving in your x direction. So that should be, okay, x minus 3. Okay, should go inside your first set of parentheses. The vertical distance from any point xy to the center is y. Okay, that should be y plus 4. And then the total distance from xy to the center is the radius of the circle 7. The blank can now be used to create an equation that shows the relationship between the horizontal, vertical, and total distance of xy to the center of the circle. Okay, and that's going to simply be the distance formula. Because again, truly that's what we're looking at. Okay, is there distances in order to come up with those? I think the key thing with that one, I think the first part to writing the equation of the circle is the part that's there. I think the reason this one probably got thrown out was the fact that you're using the distance formula rather than trying to use the equation of a circle. But that's one of the key things for the end of course test is using the equations of the centers of a circle. Where I think you're going to see this is something like this. Now remember in our last lesson we worked on completing the square. And this is where the completing the square is going to become important. We're going to find a center radius of our circle, and then we're going to graph our circle. So the very first thing we have to do is get our 16 to the other side. Okay, and to do that, we're going to obviously add 16. Now I'm also going to take and I'm going to rearrange my equation. So I've got x squared minus 8x plus some number that we're going to fill in here in a second, plus y squared plus 4y plus some number that we're going to fill in a second. And I'm going to have 16 plus 2 blanks to represent the numbers that we're going to put in when we do our completing of the square. Because remember, we're going to have to get x something squared inside of our parentheses. So if we take a look here, remember to complete the square on x squared minus 8x, we're going to take our middle sign and bring it down. And then what's half of 8? Okay, it's going to be 4. So that's going to be 4 squared. And 4 squared is 16, and that's got to go in both of our blanks. Now we need to do the same thing with y. With our y term, our sign of our middle term is a plus. What is half of 4? Okay, it's going to be 2. So we're going to have that's 2 squared. And that's going to be 4. So we had to add that over there on the other side also. Now, our right-hand side is 16 plus 16 plus 4, which is 36. And we now have the general equation of our circle. Because what we now have is a circle with a center at positive 4 for the x, negative 2 for our y, and our radius is 6, and that's what we're going to graph. So we come over here to positive 4, negative 2. There's my center point. I'm counting out 6 units. I'm counting up 6 units. I'm counting down 6 units. And I'm counting to the left 6 units. Okay? And when I do that, that's what my circle should look like. Are there any questions on that one? So what we're trying to do is we're going to try to complete the square with our x's. We're going to complete the square with our y's, and that will give us the equation for the center of our circle. And on our right-hand side, the numbers that we've added in are going to go into the radius piece. So let's take a look at another example like this one here. This time we have x squared plus y squared minus 8x plus 6y plus 9 equals 0. We're finding the center and radius of the circle and then graphing. So again, the first thing we got to do is get our 9 to the other side. And I'm going to again rearrange. So I've got x squared minus 8x plus some number plus y squared plus 6y plus some number is going to equal negative 9 plus 2 blanks that we're filling in. With our x term, the sign of the middle term comes down, and we take half of the coefficient of x. And half of the coefficient of x is what? Okay, it's 4, so that's x plus 4 squared. We square that 4, we put it up here. Remember that this 16 is tied up inside of our completed square, but that other 16 has to go to the other side, as you see. Now we're going to do the same thing with our y's. Okay, we bring down the plus. What's half of 6? It's 3, so we have y plus 3 squared. We square that 3, that 9 goes inside the first blank on the left. Remember, we don't have to worry about it because it's tied up in our parentheses at the bottom, but we do have to make sure we add it to the other side. Now the negative 9 here and a positive 9 over here cancel out and leave us with 16. And this time the equation, or our center of our point of our circle is what? Okay, it's going to be 4. Our radius, or negative 3. And our radius is 4. So we're going to go ahead and plot our points. Okay, so we start at 4, negative 3. There's our center. Our radius this time is 4, so we're counting 4 to the right, 4 up, 4 down, 4 to the left, and we just sketch the circle in. Are there any questions there on those completing the square problems? Okay, the last two example problems ask us to prove or disprove that the point square root of 2 lies on the circle centered at the origin and containing the point 2, 0. Okay, so that means that our equation is x squared plus y squared, and our radius from 0, 0 to 2, 0 is 4. So the question that we're looking at is this point here on the circle? So what we're going to do is we're going to plug it into the equation of the circle. So my x-coordinate is square root of 2. My y-coordinate is the square root of 2. And the question is, does that equal 4? Well, the square root of 2 is 2. The square root of 2 is 2. And 2 plus 2 is 4. These two things do equal each other. So the answer to that is yes, it lies on the circle. Once you can write the equation to the circle, you simply plug those numbers in for your x and y to see if they fit. And if they do fit, then your point lies on the circle. Okay, here's another example. Okay, we want to prove or disprove the point that the point 1 square root of 5 lies on the circle centered at the origin and containing the point 0, 1. Okay, for this one, our equation centered at the origin, that's x squared plus y squared. If our point on the circle is 1, that means our radius is 1. Again, what we're going to do is we're going to plug this number in here for our x and y and see if it fits. If I take 1 squared plus the square root of 5 squared, does that equal 1? That's our question. Well, 1 squared is 1, the square root of 5 squared is 5, and 1 plus 5 is 6. You can see that these two numbers are not the same, so it does not lie on the circle. Okay, the only way that those numbers are going to lie on the circle is if when you square them, they equal your radius squared. Okay, if it is greater than a radius, it exists outside of the circle. If it is less than a radius, it actually lies inside. Okay, so if it's greater than a radius, it lies outside of the circle. If it's equal to the radius, it lies on. And if it's less than a radius, it lies on the inside of the circle. Okay, at this point, we'll go ahead and stop the presentation, and you can pass out the homework, which is the worksheet on section 9.7, part 2.